Hello class 12 students. My name is Avrisha. I am your physics teacher and today we are going to learn another concept from wave optics. It's called Young's double slit experiment. So as we have discussed in last few lectures, there were two theories proposed for the propagation of light. One was Newton's corpuscular theory that light is in the form of particle, and Huygens proposed light is in the form of wave. So with the help of this experiment, Young confirmed that light has a wave nature and all the results produced were perfectly in alignment with the Huygens wave nature that he predicted. So light wave can interfere. What is the meaning of interfere? They can superimpose on each other, whether constructively. So constructively or destructively, the light energy can propagate. So now let's understand first what is this phenomenon called interference and what is the meaning of this term called constructive and destructive interference with the help of this animation. So when you make a bubble, you must have noticed they have become colorful. Inside we see rainbow like color. So that is a phenomena which is happening because of wave nature and this is the result of interference. So there are some points it becomes bright full and some point it becomes dark, relatively dark. So that we will see. Okay, so let's say this is like a particle is flowing in the form of particles and the second source is a wave. So light is a particle or light is a wave. There were two theories. Newton proposed corpuscular theory, particle theory. Huygens proposed wave theory. And this experiment, Thomas Young confirms that it is a wave. So this is like a particle. Newton proposed every light source produces a particle which travels with a very high speed. Huygens proposed that every light source produces energy in the form of wave, and that was successfully explained and verified by few experiments. One of them, or rather first one of them was Young's double slit experiment. So what is the interference pattern that was obtained? So when the Thomas Young passed the light through two small slits, this kind of arrangement was obtained. It became bright, dark, bright, dark, bright, dark. So we are going to understand how does it happen. This is a replica of Young's double slit experiment. If in a water tank you keep on disturbing at two points simultaneously, exactly at the same time, you will see a similar kind of effect that we call a water ripple tariff. This is in the water. Exactly similar phenomena in light was obtained by Thomas Young in 1801 in his double slit experiment. So how does it happen? Any light source that passes through two small slits. So these are the slits. Slits are just marked by a blade, sharp edge, so that the thickness is very, very small of the order of wavelength. They produces two light source, which is of same frequency, same wavelength, and almost same amplitude. When they constructively interfere, the path becomes very bright. And when they destructively interfere, that particular portion will become dark. So there are bright fringes, there are dark fringes. But this happens only when the two sources are of same frequency, same amplitude, and same wave speed. In this room, there are two tube lights, but they are not forming a pattern like this, like a double slit, because their frequency is not same. Why not same? That will cover in any of the next lecture. Constructive interference, destructive interference, a pattern was obtained and that pattern confirmed the wave nature. So now we'll go into depth. This is a light source which is a linear source. It produces cylindrical wavefront and the point source produces spherical wavefront as we did in the last lecture. From the light source, a light which is passed, that is passing through the two small slit, which is very thin, small cut. It's called as slit. They act as coherent source. Coherent source means having same frequency and their phase difference remains constant. When light comes out from these sources, they are of same frequency, same wavelength. They will have some phase difference, but that phase difference remains constant with time. And when these two sources light superimpose on each other, the phenomena is called interference of light, and the pattern that is obtained on the screen is not a uniform. The energy gets redistributed. Somewhere it is bright, somewhere it is dark, and that depends upon what kind of waves are superimposed on each other. This phenomena is called interference of light, which is because of superposition of the light waves coming from two sources. One is from S1, other is from S2. This is a wavefront produced by S2. This is a wavefront produced by S1. The two waves superimpose on each other. If they superimpose in same phase, they become brighter. That's called constructive difference. Light wave coming from S1, light wave coming from S2, they both superimpose on the screen. When the same phase means both the maximas are superimposed, it becomes brighter, intensity becomes more, and that is obtained as a bright fringe. It is obtained repeatedly, so there are so many bright fringes. But when the wave comes in opposite phase, their opposite maxima superimpose on each other, they nullify and the amplitude become almost zero, intensity become almost zero. If they have exactly same amplitude, it become completely zero. Means it will become a dark fringe. So bright fringe, dark fringe, another bright fringe, another dark fringe. A pattern is obtained on the screen. That's called interference pattern. But this will obtain only when light is of coherent source. Means same frequency, same wavelength. In room, we are not having any of this kind of setup. This will be only obtained when this gap is very, very small and the order of this slit is exactly similar to the order of wavelength of light, which is of the order of 10 to the power minus 7, 10 to the power minus 6 meter. Means in our daily life, we are not able to see the phenomenon of interference only when the thickness is so small that it is of the order of wavelength of light. X is the distance between the two slits, which is again very, very small, so that we get a broader pattern and we can see this on the screen and we can feel it. The screen is kept very far, again to keep the vision angle bigger, and we can get a pattern to see. The light sources superimpose on each other. When they are in same phase, it makes a bright fringe called as maxima. When opposite fringes, opposite phase of plane superimpose on each other, that forms a dark fringe. So in YDSE is basically when there are two waves coming from a same source called as coherent source of same frequency, same wavelength, superimpose on each other, they form alternate bright, dark, bright, dark, bright, dark fringes called as maxima and minima obtained by constructive and destructive interference. So again, you can see the visual representation, the wave coming from source S1 and S2, they superimpose on each other and they form a interference pattern. So Young's double slit experiment was the experimental demonstration that light is a wave, and it follows exactly the same principle that Huygens proposed. Huygens explained all the concepts, all the phenomena, which Newton's theory could not, until the new observation was there, that is photoelectric effects, and that we will see in modern physics. So that's it for today.